4 7-bit binary values are transmitted from one computer to another. A parity bit is added to each binary value, creating 8-bit binary values. All the binary values are transmitted and received correctly. Question C says, the data is sent using parallel half-duplex data transmission. Describe how data is sent using parallel half-duplex data transmission. I'm going to draw a diagram to represent this situation. This diagram represents two devices or two components connected together by 8 individual wires. This is a representation of parallel data transmission, where we can send one bit over each wire at the same time. The opposite of this would be serial, where we only have a single wire connecting A and B, and we can only send one bit through that wire at a single time. With this setup, we're able to send multiple bits at the same time, meaning we can send data faster. The second part of the question says that data is sent using half-duplex. Half-duplex refers to the data transmission technique which only allows the wire to be used in one direction at a time. So whilst A is transferring data to B, B cannot send data back to A at the same time. Data can only be sent in one direction at a time. So let's go ahead and write in the answer. The first thing we can say is that multiple bits are sent at the same time, and they are sent over multiple wires. Then to reference the half-duplex data transmission, we can say that data can be sent in both directions, but only one direction at a time. And there we go. That is the first part to our answer. The second part of this question says, state 2 drawbacks of using parallel data transmission. If we're looking at the drawbacks or the disadvantages of something, we can just look at the advantages of the opposite, and maybe they would coincide. So the method of serial data transmission is where we only have a single wire connecting A and B. This means that we can only send one bit at a time through this wire. This would mean that the bits would arrive in the same order at B that we sent them at A. So there would be no need to rearrange the bits. Given that the bits arrive in the correct order, we can send data over a very long distance, and the bits will always arrive in this correct order. So serial works very well over long distances. The last advantage of serial is that since we're only using a single wire, this is very cheap to set up, since we only have to purchase a single wire to connect A to B. Now we've written down the advantages of serial. Let's see if they correlate to the drawbacks of parallel. The first one, we say that bits arrive in the correct order. The opposite of that would be that bits arrive in a different order. If we look at parallel data transmission, every wire we have is always going to have a different data transfer rate, meaning that the bits aren't going to arrive at the same time. If we're sending over multiple bytes of data, then those bits might become skewed. In other words, they might arrive out of order. So that works for our first drawback. Let's write that in. The second advantage about serial is that it works well over very long distances. Does the opposite apply for a drawback for parallel? Well, the opposite of this would mean that it does not work well over long distances. Given that each wire in our parallel setup may have a different data transfer rate, the longer we extend the wire, the more skewed these bits may arrive. So yes, that does work as a drawback. Let's write that in. Even though we've completed both drawbacks, there are still more drawbacks we can think of. The last advantage we wrote for serial was that it was cheap to set up. The opposite of cheap would be expensive. And yes, you can imagine that setting up more wires is going to be more expensive than setting up a single wire for serial. So if you weren't able to think of these two, you could always put that setting up the system is going to be more expensive than setting up a serial system. But there we go, there is our question completed. The data is sent using serial duplex data transmission. Describe how data is sent using serial duplex data transmission. To describe how serial data transmission works, I'm going to draw a diagram. In this diagram, we have two devices, device A and device B. They are connected with a single wire. This is what we call serial data transmission, where we can only send one bit at a time. If we want to send an entire message, of multiple bytes or multiple kilobytes, we can only send one bit from that message at a time along this wire. The second part of this question refers to duplex data transmission. Duplex data transmission means that A can send data to B at the same time that B can send data to A. So data communication is bidirectional. In other words, in both directions and also at the same time. Let's go ahead and write this in our answer. First off, referring to serial data transmission, data is sent one bit at a time. And then referring to duplex data transmission, data is sent in both directions and also at the same time. And that would give us 4 marks. 1 mark for saying that data is sent one bit at a time, 1 mark for mentioning a single wire, then 1 mark for mentioning that data is sent in both directions, and 1 mark for saying that data can be sent at the same time. The second part of this question says, state one drawback of using serial data transmission rather than parallel data transmission. So, to figure out a drawback or a disadvantage, we can think of an advantage of the opposite, which is parallel data transmission. With parallel, we can send data over multiple wires, meaning that data can be sent at a faster rate. So that is our first advantage, that the data transfer rate is faster, and the opposite of this is then going to be true. That with serial data transmission, the data transfer rate is going to be slower. Let's write that in for the answer. And there we go, that is our question completed.